Today we'll be talking about geometric series. So the only difference between a geometric series and a sequence is that now we're using addition, so we are finding sums, and again this should be a geo series. Okay, so a geometric series is just like a sequence, except now we're adding. It's the only difference. So again, this is a layman's term definition. It's not an official definition, but it's my definition. So again, we're finding sums, and this is just very similar to the arithmetic, except now it's going to be a couple of different options on this one. These two formulas are very similar. They're both used to find the sum, and basically the second one, all you've done from moving from the first one to the second one is factoring out the a sub 1 on top. Other than that, they are exactly identical, so most of the time you're going to be just using one or the other, and it really doesn't matter which one you choose. So example 1, contagious diseases spread quickly. 5 people are ill during the first week of an epidemic, and then they progressively get more and more sick. So 5 people started out during the first week. Each person who is ill spreads the disease to 4 people by the end of the next week. That's the same thing as saying that R is equal to 4, because each of these people, each of these 5, if they spread it to 4 more people each individually, that means that our next term will be 20. There will be 20 total people that are sick the next time. So at the end of week 2, we've had the 5 original plus the 20 new. We'd have 25 people sick total. So what we can do here is we can find the sum. I'm going to use the second formula. Again, it really doesn't matter here. And again, I'm doing the sum, and it says we want 10 weeks. So n is 10, and we want the sum of the 10th. So we have a to the first, which is our first number. We have 1 minus, our r was 4, our n was 10. That's all over 1 minus our r, which our r was 4. And now we simplify it. So we have 5 times 1 minus, and when I did 4 to the 10th, that's over -3. So this, although this looks a little crazy on top, that we're going to be doing 1 minus this giant number, it will actually, the negative down here, this will become negative, and we're dividing by a negative, so it should become a positive at the end. So when we do 5 times, it's 1 minus this, so it's going to be -5, 7, 5. And then that's all divided by -3 here. So we still have our sum of 10. When we multiply this together and simplify, we get our answer to be 1,747,625. Okay, so again, it comes down to identifying variables, plugging them into the formula, and solving it out. Okay, I want you to do this one on your own. I want you to hit pause, and then resume when you are ready. So identifying our variables and solving it out, we get 1,023 dominoes used. Okay, here we're going to use sigma notation, so we're going to evaluate this. And again, if you remember from sigma notation, this is your first, your top is your last, and then here is what defines it in between. So another way of saying this, if we're trying to find the sum, is if we're trying to find a sub 1, then we're plugging 1 in here, and we get 5. If we are looking for the sum of all 6, we have to know what all 6 of them are. So our first one is a sub 1 is 5. If I find what a sub 2 is, because I'm going to have 5 plus something plus something. Basically, I'm going to have 6 spots here. 1, 2, 3, 4, 5, 6. When I plug 2 into this equation, I get 2 to the first, which is 2, which is 10. When I plug 3 in, I get 2 to the second, which is 4 times 5, which is 20. From here, if I look here, I can identify this is multiplied by 2, this is multiplied by 2. That means that this next one's going to be multiplied by 2. It's going to be 40, it's going to be 80, and then it's going to be 160. And what we can do here is we can add all these up, and when we do, we get 200, 315. Okay, so I think that's the easiest way to do it. Again, if you have another method, you can go for it. I think that when it's 1 through 6, it's very low numbers, very easy to just plug those in and find each number, each term, and then add those terms together. Okay, I want you to do this one on your own. It's a little bit more difficult, but follow the same steps. Hit pause, complete it, and come back to it. On this problem, I want to point out the relationship between one of our previous used formulas for the position number in a geometric sequence and what this one's set up as. If you look at this, this essentially is your a sub 1. And 3 is your ratio. So as long as you start with -4, you're going to add, and that's -4 times 3, which is -12. So again, we're adding a -12. And then if you multiply that by 3, we're adding a -36. And we're doing that 5 times. So we've done it 3, 5. So we go ahead and finish the problem. And again, we could plug each of these numbers in, 1, 2, 3, 4, 5, and then add those together. But if you can find a pattern, find the pattern and use the pattern. We'll do example 3 and example 4 as part of our class examples, so don't worry about those. Those are where we'll pick up in class.